clarification and looking at a solubility curve, which is table G. So the level of saturation is based on the amount of solute that is dissolved in the water. So I want to point out a couple of things here, is that our graph here is specifically based on 100 grams of water, and that is our solvent. So 100 grams of water, that is the amount of solvent that is present, okay? And the solubility is how many grams of this solute can 100 grams of water actually dissolve? And when you look at the x-axis, this is the temperature of the solution. The next thing I want to point out is that you will see all kinds of lines or curves on here. So for example, we have this line, and then there is a tiny arrow pointing to it, and there's a chemical formula Ki. So this is the solubility curve for the solute Ki. So all these little formulas are the possible solutes you could be asked questions about. So we have one solvent, water, and we have all kinds of solutes. So I always caution every year is take a look down in this area. Our solute curves crisscross like crazy, and it's easy to pick out the wrong solutes curve if you're not paying attention here. The temperature, this is the temperature of the solvent. Now, I want you to take a look here. There are some other clues I want to point out, is that you will notice that as the temperature runs from 0 to 100 degrees, so as you move across the x-axis, most of the curves go up. They're ascending. So the solubility increases for most of these samples as you move to a higher temperature. But you will notice that there are a couple of curves on here that move oppositely, that as you move from 0 to 100 degrees Celsius, the solubility curve actually decreases, like NH3. So this gives us a clue about materials whose solubility actually decreases with an increase in temperature. That gives us an indicator that this is probably a gas. Gases are less soluble at higher temperatures. Okay? So let's take a look here. So a saturated solution, the perfect amount of solute is dissolved in the 100 grams of water at that temperature. So the way that you know a solution is saturated is that the XY coordinate, the data point, when you put it on the graph, it lands actually right on the solutes curve. Now, if the XY coordinate actually is below the solutes curve, we describe it as an unsaturated solution. And then we have something that's called a supersaturated solution. So this is typically used in candy making. This is when the XY coordinate is above the solutes curve. It's more than the maximum amount of solute is dissolved by the water. So let's start looking at a couple of questions here. So first off, just using the graph, okay, and starting with one coordinate, either an x coordinate, what will the y coordinate be? Or we start with the y coordinate, what is the x coordinate going to be? So first thing, it says how much KCl. So the first thing that I need to do is actually go find KCl and find the line that it's pointing to. Okay, so I got to make sure I'm looking at the right curve. So KCl, I've got the right one. So how much KCl is needed to make a saturated solution in 100 grams of water at a particular temperature? That means I want my data point between the temperature and the mass to be on KCl's line. So I find 50 degrees Celsius and I follow it up until I hit KCLs, and then the mass of KCL, I'm going to read it off of the y-axis. So I can see it reads between the 40 and 50, and it's probably a little bit closer to the 40. So I would say 42 grams. Now we have a little estimating here, so I would say that a reasonable answer would be plus or minus 42. So if you wrote 41 grams, 42 grams, or 43 grams of KCl, any of those would be reasonable. Now take a look. Well, if the temperature is 95 degrees Celsius, will it still only be 42 grams of KCl, or more or less? So 95 is between the 90 and the 100. So make sure I know where I'm looking, and I'm going to follow it up until I hit KCl's curve, and then I run a read again. So I know that it is falling between the 50 and the 60 on the x-axis. It seems to be, pretty darn close to the center. So I would say around 55 grams of KCl at 95 degrees Celsius, maybe 56 or 57. Now, I want to look at a second type of question. So once again, determine the temperature of 100 grams of water to make a saturated solution of the following solutes. That means I need to be on their curve. This time, when I'm looking at it, I am given the number of grams, and my unknown is the temperature. So I know that I need to end my sample in a temperature. So this answer has to come off of the x-axis. So my answer comes from the x-axis. My starting information is the y-axis, and I notice I'm using HCl, which is a little bit different for this. So I need to find HCl, and here is the HCl's curve. Oops, not doing a good job tracing it. So we're at 62. So that means I need to be a little bit above the 60. I'm going to follow it across, and then I have to read down. So the temperature needs to be a little bit more than 40, but less than 50. And it seems to be just slightly past the 40. So I would say a reasonable answer here would be 42 degrees Celsius, maybe 43 or 41. Now we are back to the KCl. So that is already the curve I highlighted in blue. So we are starting off with 52 grams of KCl, so a little bit above the 50 line, and I need to follow that all the way across until I hit the KCl. And so it looks like to me it's hitting the KCl line just before the 90. Now, it is a little bit small and blurry for me on here, but if I did this right, it's falling between the 80 and the 90, and the where I hit it, it seems to be like a little bit, maybe slightly close to the middle between 80 and 90. It's hard to read on the screen. So I'm going to say probably around 85 degrees Celsius. Reading this on your actual table G, it might be a little bit closer to 84.